first, we're gonna take a look at the narrow diffraction patterning in both TEM mode and STEM mode. So right now we're at the TEM mode, so we're gonna do narrow diffraction at TEM mode first. But before we do narrow diffraction, it's good to go through how to take a look at how to take a conventional select area diffraction pattern. So first we need to let's open the corner valve, find the region of interest. Put the screen down. As I mentioned, once we take a look at microscopy, before we do anything, we should always check vacuum, whether vacuum is good or not. And now since vacuum is pretty good, then we can just zoom out and then we will move out of sample. We can quickly check the alignment to see alignment is good or not. I think it should be good because it should be very stable. Okay, C2 is good. And we get a little bit high mag. We check. Oh, pin tilt is not good anymore. So we can, before do a diffraction element, it's good to go through this direct element very quickly. Okay. And then we don't need to do the camouflage element because we don't need to go for high resolution imaging. So it's good to go through a little bit the gun shift. So let's do gun shift. Pin setting. Go to spot 9. And gun shift is off. Move to the center. And then go to this way. Yeah, it's off. So every day we come in, we should do some fine adjustment of the direct element. So you see your concept is still off. So you can bring it back very quick. Okay, it should be good. Okay, it's good. And then we can go to the sample. I think the rotation center should be good. Okay. And then we're ready for taking some select area diffraction. So this is single crystal. So but the sample have some contouring here. So the diffraction on this region and on this region is different. So we can first take diffraction right on the sample. We go here. So to do a select area diffraction patterning, we need to use the select area aperture. So we just simply go here. Let's update location. Okay. So we spread the beam. We find the right magnification, and then we insert the shutter aperture. So we can start from the largest one. So you can zoom out to see the edge of the aperture. So this aperture is pretty large. You see, this is your edge of the aperture. You see, if you go for 800, you see you got a very large aperture, so you can select the whole region, and then you push diffraction button. You go to the diffraction mode, and then you need adjust focusing of your diffraction pattern. So focus, get the diffraction. You gotta find the smallest spot, and then if you diffraction is not at the center, you can use diffraction alignment to move the beam to the center. Okay. And then this is diffraction alignment diffraction pattern. You can zoom in, increase the camera, then camera lens to make you get a bigger field of view. Get a small, bigger field of get yeah. And then you can refine adjustment of your. So we can take the diffraction pattern either by fluid cam or the silicon. Usually fluid cam just for like you take a very quick, because fluid cam have a very high dynamic rate. You can get a diffraction pattern very quick by fluid cam. If you don't care too much for the quality, you can just go for high res, Lucent, and you can go for each. Usually I go for high diamond range mode, and you can use the center mode to further increase or decrease your contrast. And also you can go here to adjust your contrast. You can just see gets rendered. Okay. Once you found the image is good, you can go here, just take snapshot to the TA. You're gonna get the image in the TA. So this is the image you just get, but probably need to adjust the contrast to make. Okay, your center spots are a little bit big. You can do a little bit of fine focusing. Okay.
So you're using the focus knob when you're doing this?
Yeah, I use focus knob, and also you can use the intensity knob to bring a little bit, give a little bit more intensity. But you say when you don't change the shape of the don't change shape of the diffraction pattern if you give a little bit more intensity. Another thing, you can insert the object aperture. So that's gonna help you do a kind of a focusing. If you go not focusing, you see you don't see the edge. The edge of the objective aperture become very blurry. You want to find the sharpest edge. Yeah. So now you know you get a very good focusing. All right. So if you insert the object aperture, that's gonna help you help you with the focusing. And you can get another. You can insert the beam stopper because the center spot is very strong. You can use a beam stop, and you can use diffraction alignment to move to do some like movement to align the center spot with the bin stopper. And then you can just take another snapshot, GTA, open that. This is your new one. You can adjust contrast. So this is how a sampler take an image by using their float cam. You can give more intensity. Don't change the star size. Okay. So and then you can using their Citacam to take an image. For use a Citacam to take an image, so we need to set up the camera first. So we definitely prefer to use the beanstalk because the center spot is very strong. It might affect your diffraction patterning. So we can using the different we can set up preview first. So preview we can do 1K by 1K imaging, and we can start from very low exposure time. But we can do more frame combining. We can do 10 frame combining. So this is first decrease your frame time. Maybe each frame is 100 milliseconds. Then we can do 10 frame. That's gonna be if we do 10 frames, that's each frame gonna be 50 milliseconds. So this is your preview. If you find this, this is just preview to give you idea how it's look. You can just take a look 50 millisecond one frame to see how image look like, and then you can determine the detail setting for your capture. Basically, for the capture, at least we definitely need to do frame combining. That's gonna limit your time per frame. So you can do 1 second, and if you do 20 frames, it's gonna be 50 frames millisecond per frame. So in this case, you can protect your camera, right? So let's take a look. The shortest exposure time to see how image look like. So this is your, because right now you use the shortest exposure time. This is how your image look like. You want to clear any notation, put 0 there. Okay, 0 the notation, and this is how this is 50 millisecond and 1K per 1K image. This looks good, and then you can just go here, go to the capture, you go 20 frame, you average 20 frame, and using this acquire. Make sure you select image pattern. Okay, and then you acquire. The total time gonna be 1 second, but you're gonna each time, each frame gonna be this one you can select this full readout mode. Okay, this is basically your diffraction. You see, you get a very good diffraction, right? You get a good range. You can adjust contrast a little bit. So, and then you can read especially you can go process data processing. You can use the non-profile here for data processing and select this brightest spot and take a look how much count you get in this brightest spot. You see you get a 2,000, over 2,000, almost 3,000. That means you can further, that's for the 20 frame, right? Which is okay. So because you get 20 frame, that means each frame you just get about 100 count, right? So this is very safe for your camera. So you want to make sure your image is safe. Another thing, you can just use the one frame. You can just go here. You set up a quick acquire. You can go small design, and you can just acquire a single frame. imaging, and then you can take a look. This is enough to go for this one, the corner image. And then you take a look at your data processing. So, and then you can journal. You can see. So for this one, you got the 800 count, right? So the max count is for the 800 for frame. So you don't want to go over 8,000 counts per frame. Okay. So anyway, this is good. So we do for diffraction patterning. We highly recommend you do the frame integration. Do the average more frame. You set a very low exposure time per frame, but you go for at least 20 frames. So and then you can go inverse context. This button, you click this button, you inverse your diffraction pattern. Okay. We just make this spot highlight this diffraction spot. So what that means, usually I do preview if I go. So this is a process. If I set up the aperture, but now 800 probably too big, and also you can lower the intensity. So if you go for more intensity, you probably need to change your exposure time. You lower the intensity a little bit. Use the intensity lock, but don't go over, like you don't want to change the shape of your diffraction pattern. Use intensity lock. And then you can you get the right select aperture, and then you go acquisition, and you can preview how much count you get per with minimum acquisition time, minimum exposure time. Once you did that, you get the idea how much intensity you get in this map. Actually, for this one, you get almost 8,000 here. This is some spot you get almost all exposure. So that means that you cannot go beyond this one. So you need to choose smallest exposure time. If you get the count over maximum here, over 8,000, you probably need to lower the intensity. So let me lower the intensity. You lower the intensity, and then you leave the screen, and then you check again how much count you can get on the single frame. So then you say your max count is 3,000. That means it's safe. So, and then you can set up the acquisition for multiple frame. Each frame is 50 milliseconds. So you need to do a combination. So you can adjust intensity lab to give less intensity. And then also you can choose the smallest exposure time. First choose smallest exposure time, and then lower the intensity. And then take a look at this. You get a single frame imaging, and you take a look at the max count here. You see your max count is close or over 8,000. You need to further lower the intensity. Use the intensity, reduce the CH value by using the intensity log here. Okay, or you can use a smaller aperture, maybe because another thing you can do, you can lower the screen. You select smaller, select aperture. You can further reduce the intensity, reduce the electron goes through the aperture. And then we can take a look how it looks like. Okay. And we need to use stopper. Okay. And then you can go leave the screen, use relax, and just go preview. And you say you read the max intensity, it's almost 8,000, then you need to lower the intensity a little bit. Okay, go, okay, this is right. So the mask count is below 7,000. So you find the right intensity, right? Once you find the right intensity, I can just stop view, and then we go set up the repetition. I go 20 frame. For 1 second, 90 frame. Because I cannot go 20 because it requires minimum acquisition time. So, and then you go take the acquire this image you get. In this case, you're not gonna overexpose your camera. If you find this exposure is not good, you need to further increase the contrast. You can go for more frame. You can go 2 second, 40 frame. Actually 38 frame, and then you get another image. To say the contrast is improved, and also you can use the animation. You can use a little bit of filtering. You can do averaging filtering. Averaging filtering gonna improve your signal to noise ratio. See, this is before, this after average filtering, and you can try different filtering to make it better. This is your high pass. You can do Gaussian barrier. Increase the breed. Okay, there's a lot of things you can do after you get diffraction. So several key points. First, you can adjust the key point into when you take diffraction pattern. The key point, the first thing you need to focus in you need to select use the select area, aperture, select the region, and then you need focus lab to focus on your insert objective aperture to focus on your object aperture. In this case, you will get a good focusing of your diffraction patterning. That's the first thing. You need to get a good focusing. You need to select the region. The second thing, you need to adjust you need to determine what kind of exposure and intensity you will use. In this case, you can better protect your camera. Also, you can have a good signal to noise ratio. So you go for lowest 1K by micro imaging and go for lowest exposure time. And then you're also gonna use the intensity lab, lower the intensity to make very weak beam, and then you go take an imaging. You go for live view. You take a look how much count. You read the max count in the object property here. Make sure your max count not go over 8,000. Once you find that's good value, you can stop view and you can set up the acquisition. You can go multiple frame. Usually, I recommend go 20 frame for at least 90 frame first, and then the sample mass count is your go for exposure time 1 second. That's gonna give you every frame gonna give you about 50 milliseconds. So you know there's a safe, and then you can acquire a diffraction patterning. So and then you can further use smaller cell aperture. In this case, you can further reduce your intensity. So you go natural. So So right now, your SIM's reflection pattern is very weak. You can increase the intensity to make it a little bit strong. Okay. And then you leave the screen. You go for acquisition. You choose the smallest acquisition. You go live view. Now you say you need more intensity, right? Because use the small aperture, you get less electron go. So then you need to use the intensity lock C2 to increase the intensity. And at the same time, you can read the max value here. You don't want this max value go over 8,000. Okay, that's good, right? It's about 66,000. About 6,000. It's below 7,000. You can use diffraction element here for to block the central beam. Okay. Once you feel good with that, you can just stop view, set up the acquisition. You go 1 second, 20 frame, and then you can acquire image. This is how simply we take an imaging. After you get the imaging, you can do some filtering to make image look nicer. Okay. And then we can go smallest one, 10. This is smallest one, 10. And you leave the screen. Quick look application, you go preview. You're saying you need to. Now, even you adjust intensity, you cannot get good count. Then you need to increase your exposure time. You can go 100 milliseconds first to see it's good, and even you can go 200. So now it's give you good count. That means for each frame it's gonna be 200 milliseconds. Then you set up your parameter. Each frame is 200 milliseconds. If you go 10 frame, gonna be 10 seconds. Also, if you go 10 frame, gonna be 2 seconds. So this is 10 frame. Let's go 10 frame. And then you can add cry. And if you want more, you can do 4 seconds, 20 frame. So my point is you have to keep your camera safe. So by using this method, it's gonna let you use your camera safely. You're not gonna overexpose your camera in this way. All right. Okay. You know, for single frame, you got almost 4,000. It's 200 milliseconds. Then you can set up the 20 frame. You can go 4 seconds, and the total time gonna be 4 seconds. You can acquire another image. Okay, and then we can stop the view. And then sit down. And then you load the screen. You can go out of diffraction. And then we can take a diffraction on different region. So you can. So your aperture is very small, right? You need to retract your aperture. You can retract your beam stop as well. Then we can do diffraction on different region. It's today's region. You can go here. Okay. You can select the area, maybe do 41. Select this region. Just adjust aperture, position, or you can move the stage. Just select this region. And then you can see diffraction. Because this region is not as long as you probably not see the good diffraction pattern. And then, this is your center spot. You get diffraction, you get amorphous ring, because we select an amorphous region. You can just insert beam stop. And then move the beam stop to the center. And then you can adjust intensity a little bit. Okay, go lower intensity first. And then you leave the screen. Go to acquisition, select this smallest acquisition time, go preview. And then you let the value, the max intensity count is almost 4,000. You can increase a little bit of intensity, go to 8,000, that's good enough. And then you can stop review. Then you can increase your exposure time. You could go, it's already 69, it's almost 7,000, that's the max you can go. So then you cannot increase your exposure time anymore. You can go for acquisition, then you can go 1 second 20 frame, clear image. And you can even go for 2 second 40 frame. It's 38 frame, that's this. Okay, this is the imaging. Not so bad. You can do a little bit filtering, average 15. Let's say after filtering, your signal mode looks, the noise ratio looks much better. You can inverse the contrast as well. Okay. So this is how we do diffraction pattern. Next, you can add request control. I'm gonna move to sample one, and then let's go to sample one, and you can get some diffraction patterning on that sample one. This is sample one. Okay. Let's focus. diffraction right now. Okay, it's your turn. So let me give you control. So if you need a hand panel, tell me how to do it, and I'm gonna move stage and also find the region you want for you.
Okay. Okay. So I guess we'll assume we did the HR or the TEM alignment already.
Yeah. Yeah.
So we'll put in the selected area aperture.
Okay. Which region?
We can move up a little bit. Yes.
I think first thing you need to tilt your sample, right? Because this haven't been set to the zone X first. Right. By the way, it's fine because you even it's not at a zone X, but you can still get diffraction pattern. Right.
So we could just go into diffraction first and look at it.
Okay. Okay. Cool. Okay. It's quite close, huh?
Yeah.
Okay. You can just leave at it and move anyway. Okay.
So are you tilting it or are you moving the sample?
I'm tilting.
Okay.
Okay, I think it's good.
Okay. We could throw in the select area aperture. Let's go. Let's do 200. Okay. We'll hit adjust. We can center it on the sample.
Okay.
Okay. We'll switch over to diffraction. We'll throw in the beam stopper, which is right. Is this one? Okay. We'll do diffraction alignment. Center behind the beam stopper. Is that the right one?
Yeah, that's the right one. You can do half insert. Here's half. You can insert. It's a half insert. Just a recheck. Okay.
All right. Okay. Now we could either take a picture with the flow cam.
Okay. Yeah. So this is we can take a look at imaging you're taking. No, fine. Can go here. This is the imaging you just took. It's good, right?
It's okay. Oh, okay. I guess we'll go back to the.
Okay.
Okay. Let's see. We could throw in the objective aperture.
Okay. Object capture.
Yeah. We could focus to get the edge of the Are we using the focus knob for this?
Yeah.
Okay. Get a sharp edge. Okay. Let me take this out. We'll use the intensity knob to focus these. Get it less bright. Okay. Then for the flow cam, we hit the.
Yeah. This for high diamond range. Use center mouse to adjust contrast. A quick image use a center mouse.
Okay, but then this is just for the flow camera pictures, right?
Okay.
Oh, so is there a way to, let's see, let's take a picture here. Is there a way, so in VLOX you showed the filter. Is there a way to filter in the TIA?
No.
No? Okay.
Yeah, here we have just have one FFT field, inverse FFT filtering. We don't have the conventional, we don't have another image filtering. So you can do filtering for your HR10 imaging, but you cannot do the filtering on the conventional, on the low mag imaging and also diffraction patterning.
Okay.
Okay.
All right. We'll switch over to VLOX then. Can you switch over to the VLOX software?
Oh. Let's lower the intensity first.
Okay.
Jason. Let me, okay.
Okay. Camera. Go to play. Lowest intensity, 1 frame. Okay, and then I guess when we go over here. So when you decrease the intensity, you just make it as low as possible, or how much it's?
It's yeah. You say it's make it's as low as possible, but you still want to make sure you're seeing the diffraction spot, right?
Yeah. Yeah.
Yeah. Can you screen for you?
Yep. Let's switch back. Switch screens. Okay. Let me get ahead. Play. So that's at 3,000, 4,000 or so.
So there's two ways, right? You can either increase exposure time, or I can increase intensity. Which way do you recommend?
I would increase the intensity.
Okay, because for the okay, because intensity is easy to do. I can just use a knob, right? I can do minor increase. It's very common. You can do a live update right there, right? You can see that now. Tell me when you want to do.
Here should be good. Below 7,000 just to be safe.
Okay.
Okay. Let's stop this. Okay. So then we'll use the second camera. 1 second. So 1 second, 20 frames.
You cannot go 20 frames.
Okay.
Because the minimum exposure time is 52 point something, 52.4 milliseconds.
Yeah, so they divide it by the, yeah, okay. Okay, so let me take a picture of this one.
Go ahead. Essentially, your image is a little bit noisy. You can increase your exposure, combine more frame, right?
Okay.
You can go 40 frame, 2 seconds. Or 38.
Okay.
It's good. If you want to increase more, you can go 3 seconds. And 3 seconds, 60 frame.
Okay,
Around
I think this is good.
76. Okay, that's a good, right?
Let's go to the processing.
Okay. Oh, okay.
Sorry.
Yeah.
Okay.
You can average more pixel. Yeah.
Okay. So was that it? Okay.
Yeah, that's it. That's right now, because you can try different aperture to do fine adjustment. Because I know your image, because this image is still look a little bit noisy, right? You're gonna try
Is how big it is?
Yeah, because you see a lot of noise. It's a little bit noisy. So let's just try different aperture to try to see if we can improve this imaging.
Okay.
So put screen down.
We'll get out of diffraction mode. Let's try 40. We'll center that.
You want to center the aperture or?
Yeah, center the aperture.
Okay.
Into the middle of the screen, I guess.
Okay.
Okay. We'll switch back to diffraction mode.
Can you increase the intensity now?
Yep. Okay. Then is this just because of where we're at that it seems like you only see this side, we don't really see this side? Or is it just because of where we're at in the sample?
Yes, the sample is not flat. You can use diffraction element, bring it to the center. It's not flat.
No,
Because your sample it's have some curtaining, right? So, because this is because I think sometimes you see there's some spot with the highlight, some spot you cannot see the other spot. That's because the location, the sample location. The sample is not perfectly flat. Especially when you use the smaller select aperture, you will see more this kind of effect. Because this is a small region, right? And then it's gonna be more region dependent.
So
Mm-hmm.
okay. Well, at least the spots I guess are smaller. So there's less noise.
You wanna?
Okay.
So that's another element called the. If you see some stigmatism on your stigmatism on you can go here, adjust diffraction. If you get a very good focusing, but you still see red shape with diffraction. Okay, you can use the diffraction alignment doing that. You see, this is how you change the shape and go there. Somewhere here, it's good.
So for the diffraction alignment, I mean, try to make these look circular, or?
Yeah. Okay. And go there. Next circular. Okay. This one is small. Okay. So now.
Okay.
Mm-hmm.
Okay. We could switch over back to Velux.
Okay. Oh, you're using the full screen, right? Okay.
Or what happened? Oh, okay.
You can go there. Just switch back. Let me.
Okay. Let's preview again. Let's check. 1 second, 1 frame.
Let me leave
the screen. Let's bring down the intensity. It's a little high. So, okay.
Let's bring down the intensity further.
Yeah.
Let's go this one, and then you can choose 100 millisecond exposure time.
Yeah. Let's go to.
Okay.
Okay, I think that looks better. Okay, let's go to second camera.
100 milliseconds, so 20 frame gonna be 2 seconds, right? 20 frame. If you go 40 frame, gonna be
Let's do it. So
4 frame.
Be 10.
It's not gonna give you enough signal. At least you need to go 20 frame, 2 seconds, I think.
Okay. We'll try this first. Let's see. Okay. 2 seconds.
Okay, it's yeah, it's you can do a little more. You can do 3 seconds, 30 frame.
Yeah, it's because like there's this static, or that normal?
This is because you get a very low exposure time. You need to improve your signal to noise ratio. Okay. Okay, you still get a. You probably need more. You can go 5 seconds, 50 frame. Okay, now it looks much better.
Yeah. We can go to the processing window.
Okay.
Yeah.
Cool. Because the center core is very bright, right?
Yeah.
So that's the reason you need a just because this way you're gonna increase your dynamic range. So in this way, variation this way. Okay. And you can try inverse the. Oh yeah. Yeah. Okay. You can try inverse the contracts as well. Mhm.
Okay. Yeah. Then how do you reset this line if you?
You can reset the range by clicking this button here. And for this one, you have to either type the default value or you need to go to the one. Or you can type default value here, one.
Okay. Okay.
Yeah. Good. You got a good diffraction pattern there. And then you can try use the select different error. You can do one more try because right now you're doing the diffraction on the silicon matrix. Next, you can select some particle.
Okay.
And go. Let's recheck the select error diffraction. Recheck spin stop. Recheck the aperture. That's well. Okay.
Alright.
And then you can move to the region change. Let's say if we have if we want to take the small region. So yeah, let's say because this way we see some defect, right? Upon like you see here, this region, you see this like this like cross tip here, or here this I think this particle gonna especially here you see. I want you to select this region to diffraction patterning. Okay. Let's go to the focus. Let's find focusing first. Okay. Okay. So, yes. Let's search find a region for you first. Okay, let's do this. You can either do here or here. Thanks. Let's see if we can find a better one. Okay, this is probably good. Let's do here. Okay.
Okay. All right. So we'll throw in the selected area. Since we only want this area, probably go do 40 first, and then we'll switch to 10 afterwards. Okay.
They're too big, right?
Yeah. We'll switch to 10.
In lower map.
Yeah. Okay. So we'll center this. Try to bring it to the center.
Sure.
Okay. We'll switch to diffraction mode.
Done.
Okay. Throw in the beam stopper. Can you move the screen up so I can see the? I still can't see the. There it is.
Okay.
Okay. So it looks a lot better. Okay. I'll just take a picture for the TIA. Let's decrease the intensity, then we can switch to Velux.
Okay. We can go see application.
We wouldn't have to check the objective aperture every time, right? Because it should be all right.
Yeah, it should be alright. I don't you see very small spot.
Okay.
Yeah.
Okay.
The thing.
Let's check the live. Let's go to the lowest first. 1 frame. Play.
What's the count? Okay, 6,000.
6,000. Okay. We'll leave it there. Oh. Let's go to second camera. Let's do 1 second, 20 frames. Okay.
Okay. We need more frame. We need to integrate more frame. Probably we can go 3 second. 60 frame.
So let's do 3 seconds.
Enter.
Okay. It looks like we still need more, right? It should be solid, right? So let's go to 5. Seconds. Should be 100 frames.
Yeah.
95. Okay.
Yeah, it's gonna take a longer time, but it's fine.
Yeah. Okay, it's a lot more solid. Yes, less noisy. Okay, we'll switch over to
Processing.
yeah, processing. Okay. Okay. Let's see, and then let's do average. Okay, I think that's
So you see this axis bar, this actual one, two, this two tiny dot.
Yeah.
I think this tiny dot is from the future I just mentioned, right?
From the what?
From the particle I mentioned. You can load screen and the out of direction. You say, I mean this particle, this particle and this particle, this two particle. It's had you say could we take a look at the HR10 on this two particle, right? It has some defect. Stacking for defect. This region you see some so you see some like elongate diffraction here. You see they're almost connected with each other. Let's indicate the stocking for future. So, but because right now we still got a lot of interference from the matrix because this is a pattern made from matrix because the aperture is still too big, right? We probably want a smaller aperture as small as possible to just select this region. That's the reason we want to do now diffraction pattern, right? Because we already have smallest room we can go, right?
Yeah.
So what if I want to select even smaller region? So that's how that diffraction patterning comes in. Okay, so to do nano diffraction patterning, first we need let's deselect the select area. We check the green stopper. And then we can we condense the beam. You get smallest beam, right? So you can zoom in a little bit. You finally centering the future. This beam shift beam to the center. So this is your beam, right? So you need to make a smaller probe just to select this the feature. So make sure you just select this feature. And then you can click diffraction. So now you're seeing some kind of a moisture ring, right? So I need to go a little bit here. Let's insert the object. Okay, this looks very good focusing. And then you can so right now you're at the microprobe mode. Right, so you need you need to just use this condense your beam to just select this region. So and then basically, and also you just use the condenser beam to just select this region. and then go to diffraction mode, and then you basically this is your pattern. So now we're at the microprobe mode, right? So basically this is your patterning. Now we're at the microprobe mode. So usually for the lateral diffraction, usually we do this at the nanoprobe mode. We want to focus from a very small probe to form a diffraction patterning. So right now you see your diffraction is not that good. You can go to the switch to the nanoprobe mode. In this smaller probe. Let's go. Okay. Can do. You find that region again. In the nanoprobe mode, you can form a very small probe. So just select this region. You see, you can have a very small probe. Here, spin shift, branch.
So you're making a small beam, and then this is basically where all the diffraction signal is going to come from?
Yes. That's the purpose of nanodifraction. But in this case, you want to have very parallel beam, so your diffraction spot might look bigger than the spot in the conventional non-diffraction pattern. In the conventional diffraction pattern. Yeah. Instead of that. Or on a sharper. Okay. the beam shift. Okay. Condense beam. This is your diffraction. So your beam not gonna look because your beam gonna enlarge a little bit because you're not gonna have very condensed beam spot because in the nanoprobe mode because if you have very parallel beam goes through your objective lens, then you're gonna form a good diffraction spot with smallest spot. But if in a nanoprobe mode, because you have some your coverage angle is not zero anymore, you have so your beam gonna not your beam is not you're not gonna form a very parallel beam. In that case, your diffraction spot gonna enlarge a little bit. So that's let's take a look how it look like. You just insert. You can make it insert the go to acquisition.
You don't need to put in the beam stop for this one? Because the intensity
Because intensity is very weak, I think. So we can just try to see how it look like. This is fun. Oh, it's too strong. Yeah. Again, we should put in stop there. Okay. I'm not sure why the central one should be not because we condense the beam. Some space. Why cannot click that? Okay. Okay. You still gets clicked. Huh. So, Let's use a smaller aperture. And then you condense the beam just in this way. Let's go. You put aperture just for limit the intensity. If you don't put aperture in, the beam is too strong. You cannot take image in this way. So let's put smallest aperture in, and then find region again. Just use a spin stopper. It's kind of a marker. And then we can check that. I can. And then we condense beam. Just select this spot. Focus. Move a little bit. Still too bright. Next is almost 2000. Become it's been too bright. So just okay. So just now we deselect this one, so I think it's good. Go to the nanoprobe again. Because just now, I thought it's too bad. Actually, it's not. If you take a look at application here, the max count is below 8,000. It should be fine. I forget to go for auto exposure. Okay. Then we can go here. Choose this region.
So the image earlier was for microprobe?
Sorry, what? What did you say?
The image you just took was for microprobe in VLux?
This is for the nanoprobe. This is a nanoprobe. So we can take one. We use the microprobe if you want. We can go for microprobe and take one, and then we go nanoprobe, take one. Okay. So this is a microprobe. Right now we are at the microprobe, right? So we go select this one, and then we condense beam. Okay. Then we go diffraction. Okay. You see this elongated spot, right? This you can see, you get a chance to see clearly. And then you leave the screen. Go for application. Down view. So this is your edge of your being. I'm not sure where this is from.
It's above 8,000.
Okay. Lower the intensity. Yeah, this is a. I think this the if you. I think right there. Okay. Go. Okay. Yeah, it's pushing the limitation. It's fine, but a little bit over. A little bit over. Yeah, a little bit over is fine. You want to see this crossover spot, right?
Okay.
You can set up application. You can go for probably 510 first. This is a good image. And go processing. Where's data? Up here. Let me close this window. So you can add a little bit of filtering. But just keep it all right. You want to see this tiny spot, right? You want to see this tiny spot. You see this connection. Yeah. So this is pretty good. You can also get captured if the emulsion free.
So I guess after this, can we go back and check how spread the beam is?
Yeah, that's a good point. Because if it's, I think the beam is probably spread a little bit. Oh, I branked the beam. Sorry. Branked the beam.
Okay, so it's not too bad.
Yeah. I think we still need if you want to still condense a little bit more, then probably we need. I think the reason I probably needed to let me think a little bit because if we go for this intensity, we cannot add just the intensity anymore, right?
Yeah, it'd be too much.
Yeah, that's gonna too much. I think let me think if other way we can reduce the intensity. Let me think a little bit. We can use smaller spot size. So we can go beam setting. It goes spot size 9. So that's gonna limit your beam current, right?
Yeah.
I mean, doing the nano diffraction in the TEM mode is limited from. It's not that convenient, but if I would recommend you doing nano diffraction at the STEM mode. It's much convenient. It's not that complicated. It's easy to do.
And then you don't have to do any alignment, or you just make sure you do the normal TEM alignment.
I think it's fine.
Okay.
Okay, let's select this region, right? Okay. And then we can go to the diffraction. Insert the beam stopper. Go to diffraction line. And do focusing a little bit. Okay.
Okay.
Then we can lift the spring to see how strong the beam is. Not so bad. 4,040 size.
Yeah.
So that means we definitely prefer to use smaller spot size.
Yeah.
Then we can go here. We can further. Actually, we can condense the beam a little bit more, right? We can get a small region. That's just fine. Okay, and then we can go 1 second. 20. Okay.
Okay.
Diffraction. If you go, let's bring the beam first. I don't want to damage sample or not because we condense beam. See data? Looks good. You can see this tiny spot, right? It's fine because you condense the more condensing, you condensing will be more. You get the large diffraction spots. You got a larger diffraction spot, so it's fine.
Okay. Okay.
We can do a little bit of focusing, maybe. Okay, this is it.
Okay. So I guess this is like we're using the microprobe here, right? Looking at the diffraction.
Yeah, and then we can switch to the nanoprobe. If you, because right now, you still get you use very small spot size, so
Yeah.
you still get a very good. You can condense if you want to condense the beam a little bit more. You can switch to nanoprobe mode. Good enough. So right now we're at the microprobe mode. So if you want to condense the beam a little bit more, because right now for this filter it's good enough, right? For
Yeah.
this particle is good enough. But if you have a very small one, if you want to go a little bit beyond, then you probably need to switch the nanoprobe mode. Then switch to nanoprobe mode. And you switch to nanoprobe mode, you take spot size, take a large small step. Spot size 9. Move the beam to the center. Okay. And then you condense the beam a little more. So this is, I just select half of the particle. Just select half of them. Okay. And then go to the again, you do fine focusing. Okay. Go to I think it's far too small. Okay. And then
Can we adjust the camera link to see it better or no?
yeah. We go smaller cameras, not cameras. Yeah, you can consider select very small region, right? Just get a few spots. Again, nanoprobe just you get very limited information compared to the microprobe. This is your local information. This is your local information. Yeah, this is local information. It looks very weird. Then you can lift the screen, same method. Trace. You can do auto exposure here. Max is Max is 2000. It's fine. You can take an image. It's very spy. It's very bright. So this is not working well. I think. For some reason it's not right. Cause pinpoint. Okay. Cause not low Mac. Alignment map it is off. Let's check the alignment of this nanoprobe. Should be looking like this. We should get a better diffraction. Let's quick reset beam. Okay. Let's do a quick check. I'm not sure we get. Okay. Center. Okay. Unsample again. Screen current is very small. Let's adjust gun tilt. compute. So this is the harness. Okay. That's good. Perfect.
Should we adjust the C2 aperture for this or no?
It's not gonna affect it too much, so we can adjust that. It's a little bit off, I know.
Okay.
Fine. We can do that. We can just put to the center. And then we can do C2 centering. Make sure it's colored. Okay. And then we select this one. Okay. This is well. We'll go for direction. Okay. Still looks weird. Um, but it's fine. Oh, I might need to adjust diffraction. Copy one, switch one. It's not from there. It's not covered there. Huh. Diffraction looks not okay. There's a focus. This is a focus. Interesting. Diffraction looks not as good in the normal.
Is it supposed to look like the micron?
It's not supposed to look like a micron probe mode. So at least you can say, because but now you can see the diffraction pattern, but you see this red shape. Maybe I can move to the different region. Yeah. Same. So seems if you use the microprobe mode, it gives us better result. Oh. Let's take a rotation center to see if we spread a beam. Okay. Spread a beam. Rotation center is good. It's good. Yeah, I think this is the best we can get from nanoprobe mode. Because in the nanoprobe mode, you converge angle. Yeah, you being have some converge angle with. So that's you cannot get very good the diffraction spot. The diffraction spot looks very weird. This condense beam somewhere. insert this aperture. Let's see if we're gonna improve. Centering. You still get a very word definition. Now looks much better. Now looks much better. Insert pin stopper. Okay, now looks a little bit better. Still look some stickment in there. Okay, I think that now looks much better. If you improve the select aperture, limit it down. Okay. We can go more 100, 200. Okay, if we go 200, 200, 2 seconds, gonna be 10 frames, right? Okay. Diffraction element to center. So I would say for the nanoprobe mode, it's really you don't get as good at the micro. The diffraction pattern is not as good at the microprobe mode. This is the diffraction we get, right? For microprobe mode, we get a much better one.
Is nano supposed to be better or no?
It's supposed to should be a little bit better. Because right now it seems we have some this microscopy, I'm not sure. So right now it seems it's fine. You don't have stigmas in here. So
It
because
looks like a spear though, right?
yeah, look at the spirit. So you can try on your microscopy because this one I probably we need to redo the advanced alignment because something goes around going on and it's supposed to look a little bit better. At least you don't see this elongated feature. Probably this is from sucking for, I'm not sure. You probably have a little bit better focusing. Another reason maybe, oh, I know, probably I have idea. Okay, probably we can try this one. Leave this, lower the screen. Load screen, and then probably we can try, okay, let's change the focus. Okay, this is I choose the smaller C2. Let's see if this works. If the, okay, if it's a smaller C2. See if this works. Just C2 centering first. Then we can go quickly adjust C2 centering. Since it's way off. Zero off. Just synthesis. Okay. C2 centered. Let's see if it's very weak. So come to that. See if we can. Okay. This let's go instantly. Okay. Then we can go find the region hinges. So, because we really use the narrow proposition in the TEML, so the alignment is not that good. So when you spend time to align this. Okay. Okay. Select them, go diffraction mode. Diffraction center. Oh, looks a little bit better. Looks better. There's the screen. Go there. Oh no. Let's go for 50 seconds first. How many more counts? More intensity, right? And go to text 1. Can go 200. Okay. You can go 500 even. The ping is very weak. Okay. 500. 7. Okay, this is the nano diffraction. Another one. You can do origin. Then you can compare your this one. Definitely, because definitely your spot looks bigger because you're at a nanoprobe. You're not getting because you at the nanoprobe you get some converge angle. The smaller, if you're at the zero converge angle, beam converge angle, you get the conventional diffraction patterning. That's in this case you get the smallest central spot. You get the smallest diffraction spot. But for the nanoprobe, you have some converge angle. You're being because this now the same situation improved because I choose a smaller C2. Smaller C2 give you smallest converge angle, beam converge angle. So in this case, your spots look a little bit smaller compared to the one I took before. So this is the reason you see a little bit improvement in the when we take a diffraction pattern at nanoprobe mode. Okay, but definitely the benefits for using the nanoprobe mode is you can go smaller probe and smaller probe to select a very small region. Okay. Yep. Just I think that's the best we can do right now. I think we can further enhance use even smaller spots. Or even large spots actually, because the beam is very weak. Oh, you get another condenser. Let's go. Okay. Select this region. Select this region. Then switch diffraction. Okay. Let me see. Now a little bit better.
So what did he do differently? All he did was increase the spot size and
Yeah.
have the condenser aperture smaller, and it looks better.
Yeah. Because this one actually, if you use the C2 condenser C2 training, it's like basically your convergence angle become very close to 0. I cannot read the value in the TEM mode, but I can read that convergence angle value in the. You see this right now. We cannot see the convergence angle here, but probably around somewhere in a few degree. So that means so right now the image condition very close to the microprobe mode. So for the microprobe mode, the convergence angle is 0. For the nanoprobe mode, the large C2 you use, the more converging the larger convergence angle you have. And the larger convergence angle you have, the smaller probe you can get. Right? Because you have large convergence angle, then you can get a smaller nanoprobe. So right now I choose smaller C2. In this case, the beam gonna look it's good enough. It's your probe size is still good enough to select that particle, right? It's still small enough to select that particle, and then we can, and also now it seems you can get a very small diffraction spot.
Okay. So this is how the nanoprobe should look like, right?
Yeah, this is normally how nanoprobes look like. Oh, I quickly have wrong button. And now you get a lot of intensity. Okay. Can go for 100. It's gonna give you. Okay. We got 100. We can go 2 seconds. Let's go 20 frames. Yeah, then you get a very good. This is a very good. I think this is a good diffraction. You can go even more. It's 3 seconds. So different. Okay, now you're starting seeing this spot, right? Let's go a little bit more exposure time. We can go 5 seconds, 50. Right. That's gonna improve your image. Okay, if you go up, you're still seeing this like the center spot. You see actually this they're split. You can see that. You can go here, inverse the context. Okay. Yeah, that's basically a very good. This is a good nano diffraction pattern. You say compare with the microprobe one. The microprobe one, you say you're still seeing some. It's not clear, right? The central one you see line, but you don't see very separation of the spot. But here it seems give you more separation. Definitely, if we can go, if you further reduce spot size, it's gonna give you more strength. And we can even go load screen. Can you even control the density a little bit? Full screen a little bit. In this case. Okay. That's the best. Maybe I can move to different location. So move to different location. You have different patterning. Okay. Okay, that's a good location. And next screen, go for acquisition, go for view first. 50 view first. Yeah, minimal count to 100. You can go 200. I think they can go 500. Yeah, so 500. You can go 10 frame. Okay. Now you see a little better separation. You see this tiny spot there, this 2 spot, indicates maybe this is a training structure there. So here. So I think this is a good nano diffraction patterning. So different microscopy may have different different setting for get the optimized diffraction patterning. So for microprobe, I recommend you using spot size 9, right, and aperture 70 or 150 to do the nano diffraction patterning. For the microprobe mode, I recommend to use spot size 6, to aperture 20. In this case, you can get a good diffraction patterning. Okay. Yeah, you still set up this region. Any questions?
No, it looks good. I think I get a better idea. But the nano probe and the micron probe, the difference makes it very clear. So that's good.
Okay. Yeah. So
you said there's a stem nanoprobe too, or no?
Yeah. For STEM, usually you still for STEM you also can do the non-diffraction patterning. You can do nano diffraction patterning at the microprobe or nanoprobe mode. For the nanoprobe mode, usually again, if you add a nanoprobe mode in the STEM, you probably need to choose this very small C2 to eliminate your converge angle. Also for the microprobe mode, because you reduce your converge angle by the choose the different probe mode. Then you can use a little bit of large C2. Maybe it goes to that. Let's take a quick break, and I need to go to the restroom very quick, and then we can go through that. It's okay?
Yeah.
Yeah, I see you in 10 minutes. Okay, I'm back.
Okay.
Cool. So we first load the fracture and go to the nanoprobe, go to the stem mode, and then we find the region of interest. Insert head detector. No scan rotation. Make sure. And then we can go to your center focus. Go back to the defocus 0, and then we need to do the alignment for the stem, right? Like this, we simply quickly go through. So you can, and then you can find the region of interest. And get the best self-image. Okay, that's good enough for the nano diffraction. Just use to bring focus. And we find the region of interest. Okay, we can do a bit of fine focusing. Let's see there. Just we want to go for. We can deliver the scan notation to its panel. Which we find that's like find that future. Okay, this is a good region. So we find that region. First, if you go park spot there, you could go park pin there, park pin on somewhere here, right? And then you go there. You take use. This is your.
Did you get the beam out again? In VLOOKUP?
You just cry. It's been gonna be somewhere in the image. You just select the pin and move the pin there. Once you move the pin there, you just quickly go through here because right now your convergence angle is 10.5 meter rate. In this case, you're not gonna see the diffraction round. You just see the center disk, right? So right now we at the nanoprobe mode. So only we can switch the microprobe to reduce the semi-convergent angle. Another thing we can do is choose the smallest C2. That's gonna the rate the value there is gonna change the semi-convergent angle change to 3. See, you get a 3 million rate. That's the smallest convergent angle you can go. You can switch to high resolution. And now you're starting to see some diffraction spots. I think you're starting to see some diffraction spot there, but you can move to different location to to see a diffraction spot. So
this is so what you're viewing on the flow cam, is that while pressing the diffraction button or without pressing the diffraction button?
Right now we are at the stem mode, right? Stem mode is in diffraction mode.
Okay.
Right, because basically you use your hard disk to because basically this is it's your central disk. You take a look at central disk. But right now I choose the very smaller C2. It's giving me not converge, giving me small converge angle. In this case, you will see the not of diffraction spot. You see the diffraction spot, they're very close to each other, right? So they're bigger than the normal diffraction spot. So this is called so-called converging beam electron diffraction. So right now we don't want to do that. We want to do the we're gonna take just normal diffraction pattern. That means we need to go to the micropore mode. Okay, in this mode we cannot get diffraction pattern, the normal diffraction pattern, nano diffraction, because this is a convergent beam electron diffraction. You have the semi-convergent angle is 33 million rate. So in this case, you see this the diffraction spot is almost overlap with each other. Right? You cannot get a good diffraction spot, diffraction patterning. So, but if you feel it's good, you can still use this angle to take a diffraction patterning, but it's not that good. So we probably need to switch to the microprobe mode. We switch to microprobe mode. Immediately you see your semi-convergent angle changed, right, to 0.6 meter rate. But first, that's when we switch to the microprobe mode. The first thing we need to do is to find the imaging, do little focusing. Let's see your microprobe image. You go up, you do focusing. You're not gonna get a very good image in there because your probe is very small, it's very big, right? So probably I can choose little bit large spot size, just a bigger, smaller spots. In this case, you probably get a little bit better resolution. Go spot size 8. Okay. Acquiring. Let me find a good spot. This is a good spot. Okay, you got a good spot. And then you park spinner. Okay, this is your diffraction patterning. Your diffraction move to center. Keep that in mind. Right now you have detector in. If you want to take your microprobe image, so use as C2 is 20. Probably go 70. Let's give you larger. If you go 70, is 4 is larger. So probably I go 20. I need to repark my beam. Park my beam everywhere. You can move your spot to see. Oh, that's a good region. So you can move your spot to see which region give you. I think this is a good region. So this is a good region, right? So then we can. Another thing we can do, we can just take out the we want to use the CETA camera to get this image, right? So we need to just go take out of the hard detector. We go acquisition, take out of that hard detector, and then you get this is your whole view of diffraction pattern. You can go diffraction. Okay, if you choose diffraction element, it's gonna choose tangent location. Anyway, we need the report being we need to move a little bit. Okay, let's say this is your diffraction nano diffraction patterning. And then We can move the beam to the center. Okay, and then same thing, you can insert the beam stopper, or you can just don't do that. You can just recheck because you either block most of the point. So we will use the camera setting to capture that. And you can select the contrast here. You can take an image by use full cam here. If you feel it's good, you can just capture full cam imaging. To take a look there, just your full cam imaging. You can adjust the contrast there. It's not so bad, right? You can lift the screen.
This is Micron probe.
This is the Micron probe. You go beam setting. This is your Micron probe. You see.
Okay.
Yeah, this is your Micron probe. You say your you got right now Micron probe spot size 8.
Okay. So basically, this is in STEM mode and diffraction, right?
Yes, STEM mode diffraction, and you see C2 is 20. In that case, you get the smallest 0.6 array. Okay, and then you can go leave the screen, and you can go acquisition. You cannot use the Velox anymore because Velox is taken by their STEM, right? It's for STEM acquisition. You can switch mode STEM, but that's gonna switch to your mode. So you need to use the Velox, use the TA for taking the nano diffraction patterning. So then you can go camera. You can go here, setting. You can set up search. So first you do one frame, no frame combining, binning 4. It's gonna give you 1 KB 1 image. We can same here. We can go 0.05, right? And then we can go search. We can also set up we can put the screen down first. So we can also set up an acquire for high dose for like 20 frame, and binning also 4. The time acquisition gonna be depend on this is 20 frame. If it's just this is 20 frame, it's gonna be 50. It's gonna be 1 second, right? Am I right? For search, it's gonna be it's gonna be 0.1. Let's say how it looks like, and then we can set up the application, right? So we leave the screen, and then we can bring this up. Okay. Can go here. You can do search. It's gonna insert the data camera in the STEM mode. This is your live view. Let's delete this. This is your live view image. So you can take your publish, you select data information. You say your max intensity it's very large actually now. You can go prime profile. Go delete this. $2,000 the max count. 2,000. You can bring the price for this. This is very old exposure, so we should go for lower exposure time. If we just press screen down, probably this is a point. Actually, it's 0.2, 2.2. And then we can take a look at the image again. 0.2 is too small. Like 0.5, 7.5 should be good. 0.4 to 0.4. Okay. Okay, which is good. If you 0.4, then we're gonna do 10 frame. If we do 10 frame, that's gonna be 0.04. Okay. 0.04 for the acquire. If we do 0.04, 0.04, 0.08 is gonna be 20 frame, right? Okay, and then we can leave the screen, acquire image. So this is your linear diffraction pattern. Oh. Keep jumping down. So you can see auto, 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 and let me place. Yeah. Can just select adjust. Okay, this is your nano diffraction patterning. You can go zoom in a little bit. Full scale. Delete the delete the image. Okay. This is how we get a delta diffraction pattern in the STEM mode. So basically, we choose the screen. Let's find a different region for that. So first, we use the relog software. We find the region. Why do my mouse keep jumping up? We go for acquisition. We install hard disk. We do a search a little bit.
Is there a way to park the spot in TIA as well, or no?
Yeah, you can park your TIA. You go here. You go STEM. You click search. Please select detector. In the TIA, you need to insert the hard disk detector. Okay, and then you go search. And then in the TA, for some reason my mouse keeps jumping. Let me go this way. Okay. TA, go here, this is your view, right? You go select this one. Then you can park your bin to different locations.
Okay.
You stop the view, and then you can park your bin to your position, and then you move your bin. And just see the you can see the interaction. You see the find a good location for that.
And then the limiting view is because the half the detector's in the way.
How many so
There's a limited view of the whole pattern because the half the detector's in the way, right?
Yeah, you're right. You're perfectly right. Yeah. See, this is something from here.
I guess, but then if we were if we're using if we use, since we don't have the half the, we'd have to lift the screen to look at the diffraction pattern, right?
Yeah. Then okay, if this is the case, you're then you have to lift the screen, get imaging, park the bin, and then put the screen down. Right.
Okay. Yeah.
To see how it bin look like, how
Okay.
the difference look like. That makes sense. A little bit complicated. You probably need to spend a bit more time. Let's say this is a good diffraction rating. Say this is probably from your particle. You can go over to say, yeah, this is a particle, right? This is diffraction from a particle. You park bin there. We go stop, and then we just recheck target detector. You got the diffraction patterning, and you go stage, you go camera, you go set up your search. For one frame, you probably go very small time first, and you leave the screen. You go search, and you take a look at your okay. Put there. You can read their object information there. You can go on fine. You can probably increase time to 1.5. Okay, and then you can go for your 0.5 acquire. And then you go for 20 frame. If it's 20 frame, that's gonna be 1.1, 0.01, or 0.1. It's gonna be 0.1. And then you see a cry. Oh, you need to leave the screen first. Sorry about that. And then you see a cry. The zero your diffraction pattern. Let's go there. Oh, this one indicates your position, right? And this one indicates your the hard effect related diffraction patterning. So this is a benefit to using the TA for acquire the stat imaging, because it gives you side by side view, right?
Yeah. You can
Okay.
move the. So then, and then is it right? It's good to use bin 4 for this.
Bin 4.
Yeah.
Right now we are using bin 4, right?
Yeah, that just increases the signal for us, right? By okay.
Yeah. It's a good thing to be binning for. If you do low binning, you probably need more integration time.
Okay.
Yeah, I think this is a good pattern.
Then unfortunately we can't use the VLUX to filter.
Oh yeah. So yeah, you cannot do filtering. Because we don't have filtering for the diffraction in the K.
Okay.
You have to make a good. You have to adjust. Make sure you get a good diffraction pattern before you're finished. After you can take a look at diffraction. If you don't certify with this quality, you can adjust parameter. For example, we can try take 4K by 4K imaging of this diffraction pattern. You can lower the screen first. You can set up the parameter there. You can go low binning. To go low binning, and then we can go for this all how many times how much time you need. But it's good to check again. Go search, low binning. Okay, and then leave the screen and go low binning. And then you can go 0.1 assistant, and then you probably pick take a look at this. Do you have a control? Because my mouse keep. Okay. Okay, good. Now
I had control, but I didn't move my mouse at all. So.
Okay. I said my mouse keep moving down for some reason. I'm not sure why. Oh, I have to move this mouse over there. Okay, now it seems fine. Now let's do a search. Okay, this is your new search imaging. Looks good. And we can just 0.1. We can set up the stop view. I can set up the application there. So 0.01. If I do acquire training frame, that's gonna be 0.01, then 0.01.2, right? If I'm right. Search, this is 0.01. If we go acquire training frame, that's 0.2. You can leave the screen, see acquire. Okay. Delete this. So just so this is your 4K by 4K image. This is 4K by 4K imaging. So from 4K, you can see, you can get a much clearer image, right? When once you zoom in,
Yeah.
you see if you see. So here is a pixel, but for 4K, you zoom in, you still seeing good good clear image.
Yeah.
The benefit for taking 4K image. Okay. So then, so we can try improve that a little bit. We gotta do 4K by 4K. Then we have G220. I think everything's good. I think this Let's see if we can move to different location. We can go for this one, this one, and then we can go for yes, search into the camera. You get a new search view. You move a little bit, and then you stop search, and then you can go here. You can mark your partition 2. So this is gonna save your partition 1, and then we can go here. You can see the orientation change when you move to different location. So this is a matrix. This is your particle. Since this region is amorphous region. Let's go for somewhere here, and then we can just recheck detector. Let's recheck the camera. We go setting. We go search. Leave the screen. Go search. You see a new search view. This looks good, and then you can acquire a new image. Then break the bin. See a new image in. Looks pretty good. And then you can use the same thing. Okay, this is basically how we got diffraction pattern from that. Okay, any question?
No.
Okay, I guess if no question, we can go for lunch, and then we will back at 2. Once it's back, we can first go a little bit practice, and after practice, we're gonna take a look how to do the converge beam electron diffraction, different mode, and TEM mode and STEM mode, and then
Okay.
finally, if we have more time, we can do high resolution STEM imaging.
Okay.
Okay, see you at 10. Bye now.